All right, cool. Well, welcome back. It's another week at Eden.
Yeah, and I'm back. I appeared back in the chair.
You are back. Are you feeling better this week?
I'm feeling great. How are you feeling?
I'm doing just great today for a Monday.
Happy to hear it. You want to get into our little quick segment of how was your weekend?
We do.
Let's do it.
All right. Well, for me, this weekend was my 27th anniversary.
Congratulations.
So, wife and I went and hung out and went to a cool little restaurant and had some fun. So, all good on Saturday. And, I'm always about a good project. So, I started in on a new one this week.
Another one.
An old school train safe restoration. Ooh. So got it and got to working on it. So maybe next week I'll bring a photo and show you where I'm at. The original plan was to go full custom on it, like paint, pinstriping, gold leafing, all that stuff. But I started getting into it, and the original stuff is underneath the paint that I'm stripping. It's starting to look pretty interesting. So I think we're going OG, old school, so it should be pretty interesting.
That sounds sick. I'm looking forward to it.
Yeah. How about you?
I had a great weekend. I was able to help my clients with some things, and I got to see some family too, so win-win.
Nice. Nice. Yeah, well, Mondays always come back around, huh?
I love Mondays.
Yeah.
All right, so how about...
Depending on the week, right? It's all good.
Yeah. Let's jump into it. Everybody, welcome back to the podcast. Today we're going to dive into power. Now, not like the rock band AC/DC, though. They're legends. We're actually talking AC/DC and EC power today. So, Charlie, you want to dive into it? What is AC/DC and EC?
Sure. Yeah, this is a sales guy's level, right? I'm not trying to break it down at a high level of engineering, but in very simple terms, AC and DC have been the two different powers out there, right? So you had Edison that was pursuing AC, which is alternating current, and you had Tesla doing the DC, which is direct current. So AC, as we all know, is what the power is in our homes, right? So that's what comes in off the power pole, runs all of our appliances. DC would be like what you have in your car, right? You store DC power in a battery. You can charge the batteries, use it, and anyways, we'll get into all those interesting side effects of what makes each one better or worse or whatever. And then like you said, you mentioned DC. We'll dive into that one a little bit too.
Yeah. So you actually already kind of touched on this a little bit, but could you go further into detail on kind of how AC and DC differ a little bit?
For sure. So, AC was those are, you go back to the 70s, right? All the fans that were coming out were AC, right? Because that's what everybody has. It was very simple. You make shaded pole motors. Since we're talking about here, got a few different fans, but this guy here is your very common shaded pole motor, right? You've got your stator, it goes in the center, you've got your copper windings in there, but there's no PCBA, right? So you're just putting power in there based on the resistance. You can generate a certain level of RPMs, and there you go, right? So this was very, very basic, and this was the first to come on in the industry.
Got it. Awesome.
So, yeah, you got AC, and then, we might as well dive right into DC, right? So, DC stuff, really started, and I should say brushless. These are brushless DC motors, because you might think of brush motors, right? Like if you have a little toy or something, right, that has a little DC motor in it that runs off a battery, right? Well, those brush motors have brushes in there, and we won't get into all that, but brush motors are very cheap. Right, that's where you can get 50-cent motors, dollar motors. These are brushless because there's no brushes in here. It's all the commutations are managed by a Hall sensor and a motor driver IC. So, but as you can see, you've got a very small axis. You don't have that whole stator in the center. This is the stator assembly with all the windings, circuit board in there. This enables tachometer functions, PWM, all that kind of interesting stuff, whereas AC doesn't have any of that.
Got it. And then you mentioned EC, and that's more the new wave of technology right now.
That's right.
Can you dive into that a little bit?
That's right. So the EC is electronically commutated. So in simple terms, think of it as you can use AC input, and then well, let me get it here. So this guy here, it's taken apart, but this whole assembly is one of our EC motors out of a blower that we talked about the other day. So the blower wheel goes on here. I just have this one all taken apart for purposes of being able to look at it. But essentially what's going on here is you have your DC motor core, AC input comes here, right? So you've got basically power transformation going on the PCBA, right? So that you can have AC input but DC features.
Interesting. So how would an engineer decide between each of the different types, and what are the trade-offs?
You know, it really comes down to when you're setting up the application and what you're selling into, right? Do your clients want to be able to plug this unit into AC, right? Which just about everybody does, because nobody transmits DC power, right? Like you can't go, like here in Huntington Beach, you can't have DC power coming out of your wall, right? You'd have to go get a power supply, have the 12 volts, and hook it up to something. Or just like your car, right? If your car goes dead, you got to get a battery charger, take it out there, charge the battery, right? Because DC doesn't come out of anywhere out of the wall. So depending on what you want to do, it really comes down to once you're inside the devices, right, the customer's application, do you plan on using DC in other areas, right? There could be, let's just take for example, like a little game you'd play at a pizza place when you're a kid that's picking up, toys off inside the little grabber claws. You may have AC motors in there, all your lights are AC. You have no reason for a DC power supply, right? And a power supply could cost you 20 to 40 bucks, right? So in that case, you're going to be like, I'm going with AC just because I don't want to put a DC power supply in. So sometimes it's very dictated for you, but if you have AC only and you need to get the benefit and the functionality of DC, that's where solutions like the EC motor can come in then. Because you can run it on AC and you get all the benefit of DC.
Awesome. So then I want to ask you, are there any clear industry preferences? Do certain industries lean towards different types of motors?
Yeah, I would say the leading industry for EC right out of the gate was refrigeration, like commercial refrigeration. So we're talking about, at the grocery store, when you're in the area for all your fruit and vegetables and all that, right? That is all that hum there are 254 millimeter fans. So there was legislation put out actually a while back that dictated that when you're constructing new facilities, you have to have energy efficient solutions. EC motors are viewed as energy efficient because if you took an EC 254 millimeter fan and an AC, you could have like a 60 watt AC fan versus like a 10 watt EC fan. So huge power savings just going to the new technology.
Interesting. And then I want to ask you one more question. Sorry, we got the 2-minute warning right there. So YS Tech has worked with tons of different applications in the past. Could you give us an example where we were able to use a type of motor and ultimately save a design process, or even help our customers discover something along the lines that they didn't even know they wanted?
For sure. But let's go ahead and take the break, right? And then I'll just go into answering that question. All right, so yeah, I've got a really good example of trying to help somebody get to where they didn't know they wanted to go. But we were working with a customer, this actually started pre-COVID, but then COVID ramped it up for a blower, right, that was used for ventilation in public spaces. So, sometimes schools, airports, hospitals, you have public spaces, they want to turn over the air. So, if you don't have your normal air handling system that's going on, they might have supplemental things, also known as fart fans, right? You gotta have them, right? I mean, it's just a common thing in every public space, especially restrooms, right? So they're like, hey, Charlie, we want to keep it totally simple. We want to have an AC unit. We need a certain amount of pressure. But one of our biggest problems is the air filter, right, in that system, they get plugged up over time. And we don't know, your service guy goes out twice a year maybe, right? Well, if something was going on, we'd really like to know about it. And I'm like, okay, all right, well, let's let's work into it and see where we go. Because I'm like, with AC units, you don't have a lot of functionality, right? You turn it on, you turn it off, that's that. So we start working with them, right? And we get into these conversations, and I said, well, I've got an EC motor, right? You can still run it on AC, so you don't need any DC power. But we've got a microcontroller in there. We've got all kinds of cool stuff. So what we were able to do is give them a tachometer so that they could monitor it and know what the speed is. But then we took it one step further, and we were able to develop a custom software package for the blower that helped it sense when it was having restricted airflow. Plugged filter, right? So that way, and being that we went in there and had all this cool stuff going on the microcontroller now, they said, well, geez, if you guys, this highest performance is something that we use, and let's just say for argument's sake, a 2,000 square foot area, but if we sold it to somebody that had 1,000 square feet or 500 square feet, right, it doesn't need to be running as fast so you don't hear it. So we were able to put a 3-speed switch on the back of the blower because it's got a microcontroller in there, and we could set it between, number 1 would be 500 square feet, number 2 would be 1,000 square feet, and number 3 could be 2,000 square feet. So that way they buy one unit, it works for all 3 different square footages, gives them different performance levels, has clog filter sensing, and a custom blower housing that went into their package.
Wow. So it sounds like we were really able to trick them up.
Yeah, sometimes you don't know, but again, we always come back, we say one size does not fit all, right? And that's where we go to work, right? It's identifying some of the things that you didn't know you wanted, right? Or you didn't know you could get it in the package that you want. So it's always our goal.
Definitely. And then we mentioned EC being the future. Can you give us a small little snapshot onto what YS Tech is doing and how we're ultimately building and growing to achieve that future of EV or EC?
Yeah, so again, EC is definitely, I would say, as it gets more and more common in the marketplace, what is needed is a more interesting cost point, right? Because EC is still expensive. I mean, when you compare a shaded pole fan to a EC fan, I mean, they can dang near be 50% more, right? So, but you get that energy savings, right? So there's a balance there. Costing is coming down, right? So that, as volumes grow and, basically how many are consumed globally, your economy of scale is what's really going to get them into the right price point. So as that becomes more and more applicable, right, then we can get into pushing them across multiple industries. But EC is just kind of, in my opinion, accentuating the fact that DC is where it's at because the controllability, the customizing of them, all the different things you can do is just bringing that into a platform that can be done with AC input. So, we're pushing out many different sizes. We're looking to get into bigger blowers, have other bigger diameter motors. So there's lots of things going on with that in the engineering department these days, and we'll definitely keep you posted as it rolls out.
Great. Well, I think we're all looking forward to seeing that. I want to ask you, is there one key takeaway that we could give to our listeners at home so they could summarize this whole episode with one key takeaway?
Yeah, there's many options for voltage choices out there, and when in doubt, give YS Tech a call and we'll help you make the right choice.
Yes, sir. Well, hey, I think we're going to wrap it up on that one. Feel free to click right here or somewhere right here, and you'll be able to get to our website or shoot us an email. I'm Eden, and this is Charlie.
All right, we'll see you guys next time.
Have a good one.